Hello everyone, today we'll start the second experiment. We'll take the real-time PPG signal through PPG sensor and calculate the heart rate. We'll be using the Metro library which will help us in sampling. We'll take 150 samples. We'll expect about 8 peaks in those 150 samples. The moving average filter will be of order 10. Sampling frequency will be of 50 Hz. We'll store the number of beats in this variable. Delay due to the sampling frequency in millisecond is calculated by this variable. We define a metro variable which will consist of delay caused by this specific frequency. We'll define two arrays of one size 150 which will store our input signal and our first derivative output. So let's start. In the setup loop, what we'll do is assign the array to value 0. Every instance of the array to value 0. Here we'll set the baud rate is equal to 19,200 and the pin mode which will be communicating with the computer is A0 and will be acting as input. Now this is the code which will be repeating infinite time. So what we are doing here is taking the input only when the sampler dot check value is 1. That is when there has been a delay equal to 1000 by 50 milliseconds. When that happens, we take the input and store it in our array and increase the value of I2. We'll do this till I2 is less than 150, that is we'll store 150 samples. Now we'll calculate the moving average filter output of the stored signal. The order of the signal will be 10. The order of the moving average filter would be 10, Here, this is the code to calculate the moving average filter. Now what we'll do is remove the mean of the calculated samples through every sample. We'll calculate the mean of samples, then we'll remove through every sample. So this is the code to calculate the mean, and in this part we'll remove that mean from every sample. Now what we are doing is normalizing our input signal. So what we'll do is we'll calculate the maximum value of PPG signal obtained. This will be calculated through this for loop, and then we'll divide by that maximum value to every sample. We'll divide every sample by that maximum value. So the value of PPG signal lies between +1 to -1. Now our signal processing of the input is over. Now what we'll do is to calculate the peaks. To calculate the peaks, we'll use the first derivative filter. This code here is used to calculate the first derivative filter output of our input signal. Next, what we'll do is calculate the moving average filter output of that first derivative filter output we just calculated. The order of this filter is 4. This moving average filter is 4. So it removes the high frequency components in our first derivative filter output. Now what we'll do is calculate those values of I where there are peaks in our input signal. So what we'll do by using this code. But let's see what we are doing. Okay, this count variable will store the number of peaks, and this condition here, this condition here, yeah, this condition here tells us whether there is a peak or not at that point. If this becomes true, what we are doing is storing that value of I in our p count and increase the count value. So we'll store all the peaks in our p count. Now what we'll do is calculate the number of beats. We'll calculate that by using this code. What we are doing is calculating the average distance between the peaks, and that average distance then help us to calculate the beats that will print out. Okay, now let me add a code to print beats. Okay, now what we'll do is let's check what our real-time input is and how our process signal looks like. So let's see what our real-time input output looks like. The blue one will be our PPG signal. The red one will represent the blue one will be our PPG signal. The red one will represent our first derivative output signal. So here it is. The blue one is PPG signal. The red one is our first derivative output. Yeah, so here it is. Let's okay. I zoomed it out, and this is what it looks like. Now see, what we'll be doing is we have to calculate the distance between this peak and this peak. So what we'll do, we use this zero. What we did was we used these zero crossings and calculated the distance between them instead of calculating the distance between these peaks. Oh, see, this is a beautiful input. Here, what we'll do is calculate the distance between this and this by using this zero crossing point, and then we'll calculate the distance between this and this by using these two zero crossing points. We'll ignore these peaks, and then what we'll do is we'll calculate the average distance between two peaks, and thus we'll calculate the beat. Now let us calculate what the beats are. Now to calculate the beats, what we'll do is we'll comment them and use serial.monitor to calculate the beats. So let's see what that. So let us calculate the beats in real time. We'll be using serial monitor. So these are noisy recordings. 1500 is obviously a noisy recording. So is 292. These are all noisy recordings. Oh, here it is. 95 is a decent value for heart rate with noisy values. So is 90. So we'll end it here. Thank you.